Assalamu alaikum dear students. Dear students, our today's topic है आज का हाइड्रोजन स्पेक्ट्रम. हाइड्रोजन स्पेक्ट्रम. Now to understand what is हाइड्रोजन स्पेक्ट्रम, इसके लिए हम क्या करते हैं, यहाँ पर हम लेते हैं एक डिस्चार्ज ट्यूब which is filled with hydrogen gas at a very low pressure. तो इसमें हम लेते हैं हाइड्रोजन गैस at very low pressure and the electric discharge is passed through it. तो यहाँ पर क्या होता है कि हमने डिस्चार्ज ट्यूब लिया, इसमें हमने हाइड्रोजन गैस फिल किया, देन वी पास द इलेक्ट्रिक डिस्चार्ज थ्रू इट. तो यहाँ पर एक रे निकलती है, रे ऑफ लाइट कम्स आउट फ्रॉम दिस डिस्चार्ज ट्यूब एंड दिस रे ऑफ लाइट इज अलाउड टू स्ट्राइक द प्रिज्म और स्पेक्ट्रो. वी हैव लास्ट वीडियो लेक्चर में हमने डिस्कस किया था दैट स्पेक्ट्रोग्राफ वो एक ऐसा इंस्ट्रूमेंट होता है जिसमें क्या होता है कि एक प्रिज्म होता है और एक फोटोग्राफिक फिल्म. तो प्रिज्म व्हाट इज द फंक्शन ऑफ द प्रिज्म का फंक्शन होता है कि जो रे उस पर पड़ती है तो उसको स्प्लिट करती है एंड देन द फोटोग्राफिक फिल्म व्हिच इज यूज्ड टू रिसीव द स्प्लिटेड लाइट. तो यहाँ पर हाइड्रोजन गैस इन अ डिस्चार्ज ट्यूब एंड इलेक्ट्रिक करंट इज पास थ्रू इट. यहाँ पर एक रे निकलती है that strikes the prism and it gets splitted and that splitted pattern is obtained on a photographic film like this. It consists of the 5 lines which are received on the photographic film which constitutes the hydrogen spectrum. So यहाँ पर एक रे निकलती है from this discharge tube when the electric current is passed through it at very low pressure. तो रे निकलती है, दैट रे इट स्ट्राइक्स द प्रिज्म. जब ये स्ट्राइक करती है प्रिज्म को तो प्रिज्म इसको स्प्लिट करता है इनटू द लाइन्स, इनटू अ सीरीज ऑफ, इनटू अ लार्ज नंबर ऑफ लाइन्स व्हिच आर ग्रुप्ड इनटू डिफरेंट सीरीज. दैट पैटर्न ऑब्टेन्ड ऑन द फोटोग्राफिक फिल्म, यहाँ पर जो पैटर्न ऑब्टेन होता है फोटोग्राफिक फिल्म पे, इसको हम कहते हैं हाइड्रोजन स्पेक्ट्रम. अब इस हाइड्रोजन स्पेक्ट्रम में क्या है, it consists of the large number of lines which are grouped into the following 5 series. Those are number first Lehman series, number second Balmer series, number third Paschen series, number fourth bracket series, and number 5th that's P-Fund series. अब यहाँ पर आप देखो कि हाइड्रोजन जो होता है बेसिकली ये रे ऑफ लाइट कैसे निकलती है. We know that हाइड्रोजन जो है it has a nucleus and it has only one electron that's present in the first orbit. Suppose like this electron is here. जब हम इस हाइड्रोजन गैस when we pass the electric discharge through this hydrogen gas, this hydrogen gas it consists of the hydrogen molecules. They absorb the energy, they get splitted up into they get broken down into the hydrogen atoms. Like this hydrogen atoms are formed, and in hydrogen atoms में क्या होता है कि nucleus is there and one electron is present in its orbit. Now जब ये hydrogen atoms absorb करते हैं energy, when they absorb the electrons of the hydrogen atom, when they absorb the energy it gets excited to the higher energy level. When it returns in the higher excited state, it remains there for a very short time. Then it returns to the ground state and it emits the absorbed amount of energy which appears as in the form of the light. जो कि एक ही इलेक्ट्रॉन है, इसने absorb की energy and then it returns to the ground state and emits the absorbed amount of energy. तो एक ही लाइन यहाँ पर हमें दिखनी चाहिए, लेकिन यहाँ पर हमें कितनी लाइन्स मिलती है, large number of the lines are obtained here. It is because of the fact that जो ये डिस्चार्ज ट्यूब है इसमें बहुत सारे हाइड्रोजन मॉलिक्यूल्स प्रेजेंट हैं, दे गेट ब्रोकन डाउन इनटू हाइड्रोजन एटम्स। वो हाइड्रोजन एटम्स जो होते हैं दे एब्जॉर्ब द डिफरेंट, उनमें जो इलेक्ट्रॉन्स होते हैं दे एब्जॉर्ब द डिफरेंट अमाउंट ऑफ एनर्जीज एंड hence the electrons they get excited to the higher energy levels, and then they return to the ground state in different by adopting the different routes. For example, यहाँ पर इलेक्ट्रॉन है, suppose we have the electron present in the higher energy state. When it returns to the, suppose यहाँ पर electron, this is the nucleus, this is the electron in the ground state. When it absorbs energy, it gets excited to the higher energy levels. Suppose this electron ने absorb की है energy, it gets a large amount of energy, it gets excited to the higher energy level. Suppose this is n is equal to 1, this is n is equal to 2, and this is n is equal to 3. It gets excited to the higher energy level. Suppose n is equal to 3. When it returns to the ground state, it can return either it directly jumps back to the number 1 level, or it jumps through while passing through the n2 level. So we get the different lines are obtained in the spectrum because of the fact that electrons जो होते हैं इनमें hydrogen atoms in the discharge tube we have the hydrogen gas, and we have the large number of the hydrogen atoms there. They absorb different amounts of the electrons present in them. They absorb different amounts of energies, and they adopt different routes while returning back to the ground state, and hence we see the large number of lines in the hydrogen spectrum. तो यहाँ पर बहुत सारी lines obtain होती है, so they are grouped into the different series. These are number first है Lehman series. अब ये Lehman series है क्या? Number first series जो है that's Lehman series. Lehman series है क्या? Lehman series वो series है जब इलेक्ट्रॉन जंप करता है from the higher energy levels to the n is equal to 1 level to ground state, that's n is equal to 1. Suppose यहाँ पर हम बनाएंगे ऐसे, that is n is equal to 1, n is equal to 2, 3, 4, 5, 6, 7. Suppose the electron it returns from the higher energy level to n is equal to 1. That's n is equal to 3, 4, 5, 6, and 7. When the electron it returns from the higher energy level, suppose we have the n2 here, n2 higher energy level जो है that is equal to 7 है, 6, 5, 4, 3, 2. तो ग्राउंड लेवल n is equal to 1, that's equal to 1 लेवल. तो वहां पर जो सीरीज ऑब्टेन होती है उसको हम कहते हैं Lehman series. So you have this one, electron returns from the higher energy level to the ground level, n is equal to 1. इस सीरीज को हम कहते हैं Lehman series. Lehman series. So Lehman series is that series when the electron from the higher energy levels, that is n is equal to higher energy level, that's n2 is equal to 7, 6, 5, 4, 3, 2 to n is equal to 1. वहाँ पर जो series obtain होती है उसको हम कहते हैं Lehman series. And this series it is seen in the UV region of the spectrum, ultraviolet region of the spectrum. This line is shown here. This is called as the Lehman series. इस सीरीज में जो ये लाइन्स हैं उनकी हम वेवलेंथ या वेव नंबर भी कैलकुलेट कर सकते हैं विद द हेल्प ऑफ ए फार्मूला विच इज कॉल्ड एज द राइट-बेरकस फार्मूला, जो हमने ऑलरेडी से डिस्कस की है इन सम व्हाइल वी वर डिस्कसिंग द बोर्स मॉडल. वहाँ पर हमने डिस्कस की थी वो फार्मूला. वी हैव 1 by lambda is equal to r into 1 divided by n1 square minus 1 divided by n2 square. With the help of this formula, we can calculate the wavelength or the frequency of the radiation we can calculate the frequency or the wavelength of the ray which is obtained in the photographic film of the hydrogen spectrum. So here you have the R का value हमें पता है, that's 109,677 सेंटीमीटर इनवर्स. तो यहाँ पर हम कैलकुलेट कर सकते हैं कोई भी फ्रीक्वेंसी या कोई भी वेवलेंथ इनमें ऑफ दिस एलिमेंट सीरीज. नंबर सेकंड सीरीज जो है हमारे पास, दैट्स कॉल्ड एज द बाल्मर सीरीज. अब ये बाल्मर सीरीज है क्या, जब इलेक्ट्रॉन जंप करता है फ्रॉम द हायर एनर्जी लेवल तो n इज इक्वल n1 जो होता है यहाँ पर, दैट्स इक्वल टू 2. तो यहाँ पर जो जंप होता है इलेक्ट्रॉन का फ्रॉम हायर एनर्जी लेवल्स तो n इज इक्वल टू n1 इज इक्वल टू 2. लेमन सीरीज में वो जंप करते हैं तो n1 लेवल, while as in case of Balmer series the electron jumps from higher energy levels to n is equal to 2. So Balmer series में n2 किसके बराबर है, that 7 6 5 4 3 तो n1 is equal to 1. So that series obtained is called as the Balmer series. And Balmer series जो है वो किस region में हमें दिखती है, that is seen in the visible region. Visible region of the spectrum, electromagnetic spectrum के visible region में ये obtain होती है. तो इस सीरीज को हम कहते हैं बाल्मर सीरीज. नंबर थर्ड वी हैव द पास्चन सीरीज. पास्चन सीरीज किससे कहते हैं, पास्चन सीरीज वो सीरीज है जब इलेक्ट्रॉन जंप करता है फ्रॉम द हायर एनर्जी लेवल्स टू n is equal to 3, n1 is equal to 3. That series is called as the Paschen series. So you have here Paschen series that electron it jumps from higher energy levels to it's n is equal to 3. This series Paschen series, that's n2 किसके बराबर है, that's 7 6 5 4 तो n1 इसका होता है 3. That series is called as the Paschen series, and this series it is seen in the IR region of the electromagnetic spectrum. IR region में ये दिखती है this series. Now we have the fourth series that's called ब्रैकेट सीरीज. अब ब्रैकेट सीरीज है क्या, ब्रैकेट सीरीज वो सीरीज है जब इलेक्ट्रॉन जंप करता है फ्रॉम हायर एनर्जी लेवल्स टू n is equal to n1 is equal to 4. So you have n2 is equal to 7 6 5 2, n1 is equal to 4. That series is called as the bracket series, and it is also seen in the which region, that's the IR region of the electromagnetic spectrum. So here we have the electron, it jumps from the higher energy levels this is also seen in the IR region of the electromagnetic spectrum, that's called as the bracket series. Now we have the another one that's called as the P-fund series. जब इलेक्ट्रॉन जंप करता है फ्रॉम द हायर एनर्जी लेवल्स दैट्स n2 is equal to 7 6 तो n1 is equal to 5. That series is called as the P-fund series. So here you have the electron, it jumps from the higher energy levels to the lower energy level, that's n1 is equal to 5. This is also seen in the IR region of the electromagnetic spectrum. So we have the hydrogen spectrum. Hydrogen spectrum जो है, hydrogen atom जो है that contains only one electron. So we should actually what we get the series of 5 lines. We get the series of 5 lines here in the hydrogen spectrum, named as the Lehman series, Balmer series, Paschen series, bracket series and P-fund series. तो लेमन सीरीज है क्या, लेमन सीरीज वो सीरीज है जब इलेक्ट्रॉन जंप करता है फ्रॉम द हायर एनर्जी लेवल दैट्स n1 is equal to हायर एनर्जी लेवल दैट्स n2 is equal to 7 6 5 4 3 2 2 N1 is equal to 1. That series is called as the Lyman series. Similarly, we have the Balmer-Paschen bracket and P-Fund series. Hydrogen spectrum में होता है hydrogen spectrum है क्या basically the spectrum of the hydrogen atom. Hydrogen atom जो है it contains only one electron, so its spectrum should show one line, but it shows the series of 5 lines. Reason being that जो हम लेते हैं hydrogen gas in the discharge tube that consists of the large number of the hydrogen atoms, and the hydrogen atoms जो होते हैं वहाँ पर उनके electrons जो होते हैं they absorb the different amounts of energy, and hence while different amounts of energy is absorbed by their electrons, and they get excited to the different energy levels, and while returning to the ground state they adopt different routes, and hence we get these lines here in the hydrogen spectrum. This was about the hydrogen spectrum. Now we have another topic in this, that is the limitations of Bohr's model of atom. This was about the hydrogen spectrum, and here we have another topic, that is the limitations of Bohr's model of atom. Limitations of Bohr's model of atom. Now first limitation है Bohr's model की. Bohr's model में हमने discuss किया what are the various postulates of the Bohr's model of atom. Then we have the calculation of the Bohr's radius, radius of the Bohr's orbit. Number उसी का another topic जो था, that is the calculation of energy of the electron and the frequency or the wavelength of the electron. And then we have with the help of the Bohr's theory, Bohr explained us the hydrogen spectrum. Now we have the last topic in this Bohr's model of atom, that is the limitations of Bohr's model of atom. Number first limitation ये है कि Bohr's model जो है it explains us the spectra of the hydrogen and the hydrogen-like species, and it does not explain us the spectra of the multi-electron atoms. आपने अभी देखा कि जो hydrogen atom है उसमें खाली एक इलेक्ट्रॉन होता है, उसका स्पेक्ट्रम कितना कॉम्प्लिकेटेड है. 5 we get the 5 series of lines. Although hydrogen it contains only one electron, उस इलेक्ट्रॉन के कितने हमने स्पेक्ट्रल लाइंस वहां पर ऑब्टेन किया ऑन द फोटोग्राफिक फिल्म आपने देखा 5 series of lines, but it does not explain us the spectra of the multi electron atoms. वो atoms जिनमें बहुत सारे इलेक्ट्रॉन्स होते हैं उनका स्पेक्ट्रम कितना कॉम्प्लिकेटेड होता है. That's the spectrum of the multi-electron atoms are highly complicated, and it was not explained by the Bohr's model of atom. So it explains us the spectra of hydrogen and hydrogen-like species, and it does not explain us the spectra of the multi-electron atoms. So first limitation is it does not explain us the spectra of multi-electron atoms. जिनमें बहुत सारे इलेक्ट्रॉन्स होते हैं उनका स्पेक्ट्रम ये एक्सप्लेन हमें नहीं करता है उन एटम्स का. So that is the limitation of the Bohr's model of atom. Number second, it does not explain us the splitting of the. यहाँ पर हमने obtain की है spectral line. अगर हम इस spectral line को पास करेंगे through the magnetic field, नॉर्थ पोल साउथ पोल, अगर हम इस स्पेक्ट्रल लाइन को पास करेंगे इन दिस मैग्नेटिक फील्ड और द इलेक्ट्रिक फील्ड, it gets splitted up. But that splitting pattern, that splitting was not explained by the Bohr's model of atom. It does not explain as the splitting of the spectral lines in the magnetic field. उसको हम कहते हैं Z-man effect. The splitting of spectral line in the magnetic field is called Z-man effect, which was not explained by the Bohr's model of atom, and hence it also does not explain as the splitting of the spectral line in the electric field. That's called Stark effect. तो दो effects इसने हमें explain करके नहीं दिए, that is the Z-man effect and the Stark effect. It does not explain us the splitting of spectral line in the magnetic field ब्रैकेट में Zeeman effect and Stark effect. Now what is Stark effect? Stark effect होता है splitting of the spectral line in the electric field. इसी तरह से इसने हमें कोई justification नहीं दी. बोर्स का एक postulate है that electron it revolves only in those orbitals whose angular momentum is an integral multiple of h divided by 2 pi. इसकी कोई justification इसने नहीं दी. So it does not explain as it does not give any justification to why the electron revolves only in those orbitals around the nucleus whose angular momentum is an integral multiple of h divided by 2 pi. तो ये है another limitation of the Bohr's model of atom. No justification was given to why electron revolves around the nucleus only in those orbitals whose angular momentum is an integral multiple of h divided by 2 pi. This is another limitation of the Bohr's model of atom. इसी तरह से है 3-dimensional structure इसने explain नहीं करके दिया atoms का Bohr's model में. These are some of the important limitations of the Bohr's model of atom. So we have the first limitation that it does not explain as the spectra of the multi-electron atoms. Number second, it does not explain as the splitting of the spectral line in the magnetic field and the electric field. इसी तरह से इसने हमें कोई justification नहीं दी regarding why the electron revolves around the nucleus only in those orbitals whose angular momentum is an integral multiple of h divided by 2 pi. This was all about today's topic. Thank you so much.